Hello everyone, welcome to my channel Cochem Academy. Now we are discussing about covalent molecules, about chemical bonding. So that one I have discussed how to draw the electron dot structure of covalent covalent compounds. Now another topic we will discuss today, polar and non-polar molecule. Now in case of covalent molecules, this terms, that is polar and non-polar molecule, will be applicable. Okay. Now you know that in case of covalent molecules there will be a difference in the electronegativity, but not much the difference in the electronegativity between the atoms. Okay, but some compounds are there where we can see the difference. Okay, say HCl, it is hydrogen chloride. Now formation of hydrogen chloride, okay, I have told you that how to draw the electron dot structure of hydrogen chloride. Now there we have seen that between hydrogen and chlorine one bond is there. Now that means one bond means two electron. One electron and one electron will be shared by both hydrogen and chlorine to make a single bond. That means this pair of electrons, this bonded pair of electrons, are shared by hydrogen and chlorine. Okay, so both will share equally this bonded pair of electrons. But here the electronegativity of chlorine is greater than hydrogen. Okay, is greater than hydrogen. Okay, now when there is a difference between the electronegativity of two atoms in a covalent bond, okay, there will be charge separation. How? Because see, HCl, here the chlorine has high electronegativity than hydrogen. So what, according to the electronegativity theory, that it will pull the bonded pair of electrons, it will attract the bonded pair of electrons toward itself more. So what will happen, that the electron density, bonded pair of electron density will move towards chlorine. Okay, that means this can be shown by like this. It will not be placed in the middle, it will shift towards the chlorine, that means towards the high electronegative atom. So this results that chlorine will get a more density of the negative charge. That means it will get a partial negative charge because the electron density is towards chlorine. Okay, so it will get a partial negative charge, and that can be shown by a sign symbol delta minus. Okay, and it can be shown delta plus because hydrogen is here. For this hydrogen the electron density is less. Okay, these results are dipole in the molecule, that means a negative pole and positive pole. Okay, and it results a polarity in the molecule, so that this compound is called polar compound, polar covalent compound. So this polarity will be applicable only for the covalent compound which have the difference in the electronegativity between the atoms. The more electronegative atoms will attract the bonded pair of electrons toward itself more than the other. So the electron density will move towards the high electron atom, so it will get a partial negative charge and other will get the partial positive charge. That will result the polarity in the molecule, so that compound will be called polar covalent compound. Okay, simple. So it is polar covalent compound. Now if there is no difference in the electronegativity, less difference in the electronegativity, then that compound will not be a polar covalent compound, and that will be a non-polar covalent compound. Okay, now this polarity can be shown like this, that hydrogen and chlorine, the electron density is moving towards this chlorine. Okay, electron density is moving towards this chlorine. It means delta minus, it is delta plus. This is the polarity. Okay, on polar covalent compound. Okay, now non-polar covalent compound, say methane. Okay, methane is a non-polar covalent compound. Now what is the Lewis electron dot structure of methane? Now carbon and 4 hydrogens, each hydrogen having atomic number 1, so its electronic configuration 1, and for carbon 2, 4. So each carbon, the outermost electron is 4. 1, 2, 3, 4. Now each hydrogen has one electron. Hydrogen, one electron. hydrogen 1 electron, hydrogen 1 electron, hydrogen 1 electron. Okay, now carbon want to make the outermost electron configuration 8, so it will not take up fully, that means it will share, that hydrogen will share the 1 electron with the carbon, okay, to make it the 8 electronic outermost configuration. Done. Now this hydrogen will have 2 electrons, so it will be stable because of the Electrode. So make circle. Okay, so these individual circles, that means these regions are single bonds. Now there is not much difference in the electronegativity between this carbon and hydrogen, so these bonds are not polar. These bonds are not polar, so methane is a non-polar covalent compound. Non-polar covalent compound. So as CCl4. So as CCl4. CCl4 is also not a non-polar, also a non-polar covalent compound, not a polar molecule. Okay, CCl4. The structure will be like this. It is also a non-polar covalent compound. Okay, and this class is only for the ICSE and CBSE students. Okay, ICSE and CBSE students. Say water. Water is also a polar covalent compound. Why? Because how to form the water? H2O, 1 oxygen, 2 hydrogen, oxygen atomic number 2,6, that means electronic configuration hydrogen 1. So this oxygen having 6 electrons, 2, 4, 5, 6, each hydrogen having 1 electron. So you have to make a circle by taking 8 electrons. So 2, 4, 6, 8. So make circle. Again for this hydrogen, next circle, this hydrogen, next circle. Okay. So what you will get? You will get this bond. Okay. Just wait a minute. Let me see this video is going on properly or not. Okay. So it is making a single bond. Okay. So each oxygen is the central oxygen is bonded with each hydrogen by single bond, and these pair of electrons are not participate in the bonding. So this one is a lone pair of electrons. Okay. So another topic we have learned here, that the pair of electrons which are not participate in the formation of chemical bond. The pair of electrons which are not participate in the formation of chemical bond are called lone pair of electrons. So in water molecule, how many lone pair of electrons are there? 2 lone pair of electrons. 2 electrons making 1 pair. Okay, so how many lone pair of electrons here? 2 lone pair of electrons are here. Okay, now from the structure of water molecule, like this oxygen is more electronegative than this hydrogen. So it will pour the bonded pair of electron toward itself. So it will get delta minus, it will get delta plus, and again for this bond. So each bond is polar. So this water molecule is polar in nature. Polar covalent compound. Okay, understood? So the polar and non-polar molecule we have done. Polar and non-polar molecule, concept of polar molecule and non-polar molecule we have done. Now see about the lone pair of electrons. What is lone pair of electrons? Lone pair of electrons. Okay, what is lone pair of electrons? That means the pair of electrons which will not participate in the formation of bonding, chemical bond, are lone pair of electrons. Okay, the pair of electrons which are not 1 minute. Okay, the pair of electrons which are not participate in the formation of chemical bond are called lone pair of electrons. Okay, so let me show you by giving one example, that say for the formation of ammonia. Okay, formation of ammonia. So ammonia, you know that the formula of ammonia is NH3. Now 1 nitrogen, 3 hydrogen, each hydrogen having 1 electron, and for nitrogen 2,5. Now this nitrogen having 5 electrons in the outermost shell, but it will take part in the bond formation with 3 single bond by with 3 hydrogen. Okay, because hydrogen having 1 electron, so it will make a single bond. 3 hydrogens are there, so 3 single bonds will be there. So just I am writing like this: each hydrogen having 1 electron, and nitrogen having 5 electron. So 2 electrons will be paired like this. I will write, and 1 electron will participate in the single bond with this hydrogen, another one this hydrogen, another one this hydrogen. Now I have to make a circle. 8 electrons, these 2 hydrogen, these 2 hydrogen. These 2 electron, every 2 electron will make a single bond with hydrogen. So what you are getting here, this region is the bond, and these 2 electrons are not participating in the formation of chemical bond. So these 2 electrons are called lone pair of electrons. Okay, so in ammonia molecule, how many lone pair of electrons are there? It is 1 pair of electrons, 2 electrons, that means 1 pair of electrons. So it is the lone pair of electrons. Now we can go into another concept from this lone pair of electrons concept, that about the coordination bond or about the coordinate bond, you can say. Okay, so the actually if a compound having lone pair of electrons, okay, that can participate in the formation of chemical bond with ions also, which having a positive charge. This concept is for only for ICSE and CBSE students. Okay, a compound having lone pair of electrons and ion having positive charge, so they can form a bond between them. Okay, and how they will form that positive charge ion, okay, can be attracted by this lone pair of electrons, because these are electrons and electrons are negatively charged, so it can accept the lone pair of electrons. That positive charge ion can accept the lone pair of electrons because that has deficient of electrons, because that is why it is positive charge. So by the between a compound having lone pair of electrons, covalent compound, and ion having positive charge, the bond formed, that is called coordinate bond or dative bond. Okay, and for your class, it can be shown by the taking the example ammonia ion, and that means ammonia compound, ammonia and water between H plus. Okay, so that can be done. So we can arrive in another concept, that is coordinate bond. Okay, the bond formed between a compound having lone pair of electrons and an ion having positive charge. Okay, and that ion will accept the electrons, that accept the lone pair of electrons. So see here, for ammonia, this is ammonia, you know. Now if it reacts with H plus, now what it will happen, that this ammonia will donate this H plus electron to the H plus. Okay, that means another kind of bond will form here. See, this is ammonia having lone pair of electrons, and this is H plus. Okay, so another type of bond will form between this nitrogen and hydrogen. That will be a coordinate bond. Okay, that will be a coordinate bond, and that will have a particular direction, that is to from nitrogen to hydrogen. Okay, and that can be shown by this one. So it is making a bond here. Okay, and as this hydrogen has positive charge, so to make it positive, we have to give a positive charge, giving a square bracket. So this is the electron dot structure of ammonium ion, and it is forming ammonium. When NH3 is joined with H plus, it is forming ammonium ion. Okay, ammonium ion. So it is the structure of ammonium ion, and it is very important for your ICSE final also. Okay, the structure, Lewis dot electron dot structure of ammonium ion is very important and can be given in your exam. Okay, so normally examiner asks these questions that draw the electron dot structure of ammonium ion. So in that case, this bond is coordinate bond. This bond is coordinate bond. Now take the example of between water and H plus. Water having lone pair of electrons, on the oxygen atom 2 lone pair of electrons are there. So this is the structure of water. Actually I am writing like this, having 2 lone pair of electrons and with H plus, so there will be a coordination bond. So you can show this one like this. Between this oxygen and hydrogen coordinate bond is there, and you have to give positive charge because H plus having positive charge. So this ion is called H3O plus ion, hydroxynium ion. Okay, this ion is called hydroxynium ion, and this one is called ammonium ion, both having coordinate bond. So if anybody asks you that give one example of compound having coordinate bond, you have to give this example. Okay, so today's video is up to this. So next day we will discuss about the another topic, that is electrolysis. Okay, so thank you students.